Welcome to Mathematics Olympiad. Let's do some more problems, mainly from the polynomials and quadratic equations point of view. Okay, so this is mainly meant for, they are little advanced, so not for 8th class students, but from class 9th to class 12th can solve it. I have added some of the BITSAT questions also in this. Okay, those can be solved by a 9th or 10th class student also. They are not complicated stuff actually. So that's why I included them in this. Let's see. Okay, let's start. Okay, if AB are roots of x square minus 2x plus 5 equal to 0, okay, then find an equation whose roots are a cube plus a square minus a plus 22 and b cube plus 4b square minus 7b plus 35. Okay, so this is one kind of problem where very normal to come in the polynomial problems or quadratic equations. Okay, so normal tendency is basically you find out roots of this one, so a comma b you will find and then substitute them into this one. Okay, but if you see, finding a comma b is not easy in this. Okay, and also if you apply your quadratic formula, that is minus b plus or minus b square minus 4ac, where you land up. Okay, b square minus 4ac, right? B square is 4 minus 4 into 5. Okay, 4 minus 20, so you get a negative determinant, right? Which means you actually, you have a negative determinant, so you have to substitute into this equation and get a quadratic equation, which is very difficult, right? A cube and b cube term, right? So all such problems, there is one easy way. So this is one type of problem, but there can be multiple problems across all competitive exams you will get, especially in Olympiad. Okay, so how to solve this? Let's see. Okay, a comma b are roots of this one, so which implies a square minus 2a plus 5 is 0. Okay, now a square is equal to 2a minus 5. Okay, a square is 2a minus 5, right? Okay, here, which means I have written a square in terms of a. Okay, correct. Similarly, a cube equal to, if I want to multiply both sides with a cube equal to 2a square minus 4a, and a square is equal to 2a minus 5. I will replace this. Okay, I replace this in this, so what I will get is basically minus a minus 10, which means a cube I am able to write in terms of a. Okay, so this way any power of a I can write in terms of a. Any power I can write in terms of a. Okay, so this is one thing which is very important concept to understand. So both the roots you can write basically any power level you can write in terms of a power of 1. Okay, same thing applicable for b, right? Now once you know this, you basically simplify this with the simple a multiples. Okay, that way you will get a and b, basically very easy, right? So similarly, b square also, b cube is equal to minus b minus 10. So now you substitute a cube plus a square minus a plus 22. This is what we need the value for. So which is nothing but minus a minus 10 plus 2a minus 5 minus a plus 22, which is equal to 7. Okay, and b cube plus 4b square minus 7b plus 35, which is equal to minus b minus 10 plus 4 into 2b minus 5 minus 7b plus 35, which is equal to 5 if you simplify. So you just need a quadratic equation with roots 7 and 5, right? Which is very simple, x minus 7 and into multiplied with x minus 5 equal to 0, right? So the quadratic equation is x square minus 12x plus 35 equal to 0. Okay, hope you understand. So the most important concept is this one. Any power of a, if a is the root of quadratic equation, any power of a can be written in terms of simple plain multiples of a with a constant. Okay, so once you know this, we can solve any of these problems. Okay, next. Okay, this is a BITSAT question. I'm just mentioning wherever it came in BITSAT, I'm mentioning it here. Okay, So this is also a conceptual problem. So I chose this because this is very important for 9th class and 10th class students to understand this problem. If your concepts are strong, it is very easy to crack any entrance exam. Okay, x square minus if a comma b are real numbers, then x square minus abx minus a square equal to 0 has what kind of roots? Okay, positive and negative, only negative, none of the above. Okay, nothing is given. It is mentioned that a comma b are real numbers. That's it. Okay. So how to go about it? Now look at it very carefully. If PQ are roots of the above equation, okay, what we need is this one: P plus Q is equal to AB, P into Q equal to minus A square. Correct? This is all we need. We understand from this equation, right? But if you carefully look at A square, if A is a real number, A square is always positive. Correct? A square is always positive, and minus A square is always negative. Correct? You can't get a negative term from A square which can negate the negation minus here. Correct? So minus A square is always negative, which means PQ, product of two roots, is always negative, which means the constant term is always negative. Correct? And if constant term is negative, that means the two roots, sum of these two, basically one has to be positive, one has to be negative. Only then it is possible. Right? Both cannot be negative, both cannot be positive. One has to be positive, one has to be negative. Right? So, which is very, now we understood the concept very easily, right? A is the answer, right? A square is always positive irrespective of the value of A, which means PQ is always negative. Okay, that means if two numbers, product of two numbers is negative, if and only if one of them is negative, right? So, one root is positive and one root is negative. Okay, that is A is the answer. Okay, I hope you understand this. Okay, this is very basic concept. Next, the difference of roots of x square plus ax plus 1 equal to 0 is less than square root of 5. Then the range of a, basically, that's what we need to find. Okay. So if p comma q are roots of the above equation, p plus q, this is the only thing we know about quadratic equations, right? Along with this, we know quadratic formula, that is minus b plus or minus square root of b square minus 4ac by 2a. Right? So with these only we are going to solve the problems. PQ are roots of the equation, so p plus q is equal to minus a as per the equation. Okay, p plus q is minus a and p into q is 1. Okay, the difference of roots is less than square root of 5 he gave. So we need to get to difference of roots. How do you get? P minus q is what we need. Is it p minus q we need or difference of roots? It can be q minus p also, right? So don't make a mistake and take p minus q. Okay, so it's the absolute value of p minus q is less than 5. Okay, now you don't want to deal with the absolute value. Simple way is square it. P minus q whole square is less than 5. Right? How do you get p minus square? Very easy. Right? P plus q whole square minus 4pq is less than 5. Right? So which means p plus q is minus a. So a square minus 4 is less than 5, or a square is less than 9. Okay, which means a is between minus 3 and 3. Correct? A is between minus 3 and 3. This is what a range actually. But you can, if you look at the equation, you can actually simplify this range further. Okay. Let's see how to do that. We did not check the discriminant of this equation, right? Okay. Discriminant we should check for real roots, right? So discriminant is b square minus 4ac, which is a square minus 4, which should be greater than or equal to 0. So a square is greater than or equal to 4, which means a is greater than a should be less than or equal to minus 2 and greater than or equal to 2. So the range is basically the in between from minus 2 to 2 is not possible. Okay, minus 2 to 2 is not possible. So the range is now cut short. Basically range is from minus 3 to minus 2 union 2 to 3, and you check the inclusion is at the 2 side. Okay, minus 2 is inclusion, 2 is included. Okay, not the 3's. Okay, so this is the range of the quadratic equation. Okay, so always check the two things. Don't leave the discriminant because we always look for real roots. If nothing is asked that we are looking, then it is real roots. Okay, next. Okay, yeah, read the problem. We need to find the maximum value of p square plus q square. Okay, this is also a BITSAT question. Okay, this also looks simple. We need to just apply sum of roots and product of roots and find out p square plus q square, right? So p plus q is minus k by 2, pq is k square plus 3k plus 5. Okay, now how do you get p square plus q square? Very simple, p plus q whole square minus 2pq, which is k minus 2 whole square minus 2 into k square plus 3k plus 5. Simplified, what you will get is minus k square minus 10k minus 6. Okay, this is what we got. Okay, now this is what is p square plus q square. Okay, okay, so which you can rewrite. You try to convert this minus k square minus 10k minus 6 into a square minus b square kind of things. Okay, so you add basically 25 because it is 10k here, 2 into 5k, you can call it 2 into 5 into k square is there, so 5 square we will add, that is 25 here. Okay, and to do that we need to subtract 19. Alright, so this will become basically 19 minus k plus 5 whole square. 19 minus k plus 5 whole square, right? And what is the maximum value of p square plus q square? Now again we need to apply same thing. K plus 5 is k plus 5 whole square is always positive. Okay, it cannot go negative for whatever value of k, correct? So maximum value you can have is basically 19 minus something. Okay, something less than 19 is minus is the maximum value, right? So 19 is the maximum value. Okay, that is very clear. And when you will get that maximum value, when this k plus 5 term is gone basically, correct? You don't need to subtract anything from this 19, then you get the maximum value, that is 19. So k should be minus 5. If k is minus 5, k plus 5 whole square is 0, right? So maximum value is 19 if k equal to minus 5. Okay, so p square plus q square maximum value is 19. Okay, so if you look at most of these competitive exams, whether it is Olympiad or any of the entrance exams, they try to add one or two mathematical concepts into one question. So this has basically a quadratic equation, okay, polynomial concepts, and also number theory, right? So number theory is very, very basic and fundamental to any problem. If you are not good at number theory, please keep reading that first. Okay, because once you understand the number theory, numbers very well, solving any of these problems is very easy. Okay, next. Okay, alpha, beta, gamma are the roots of x cube minus 2x plus 1 equal to 0. Then what is the value of this given expression here? Okay, so look at the expression carefully. This is like a series, basically alpha plus beta minus gamma, alpha minus beta plus gamma. Okay, then minus alpha plus beta gamma. This is like a continuous series, right? So we need to simplify this first. How can we simplify this? Okay, if you get alpha plus beta plus gamma value, is it anything useful? Yeah, definitely it is useful. And if you see the equation which they have given, x cube minus 2x, there is no x square term, right? So for a cubic polynomial, alpha plus beta plus gamma is equal to coefficient of square term, right? There is no square term, which means alpha plus beta plus gamma is equal to 0, right? This will give us few things. Alpha plus gamma is minus, alpha plus beta is minus gamma, and the two other things, right? So this is very easy. Now you replace this alpha plus beta equal to minus gamma into first equation. Second equation this. So each equation we can simplify with this, right? Which is equal to 1 by minus 2 gamma plus 1 by minus 2 beta plus 1 by minus 2 alpha. Now you simplify this. Now you add this, what you will get is minus of alpha beta plus beta gamma plus alpha beta divided by 2 alpha beta gamma. Now these two we can get from equation. Alpha beta gamma is equal to 1, is equal to minus 1, sorry, and alpha beta plus beta gamma plus alpha beta is equal to minus 2, coefficient of x. Okay, this is constant term, basically minus of constant term. Okay, now you substitute these values, what you will get is minus 1. Okay, this is the answer. Okay, next. Yeah, this is another question. The solution of inequality which is given there, you can read it out. Okay, so this is also, we just need to convert into quadratic equation first, right? So let's see how to do. 4 to the power of minus x plus 0.5 minus 7 times 2 to the power of minus x is less than 4. This is what is given, right? Okay, now 4 to the power of minus x 0.5, I will write it as half. Okay, and I will separate it into product. Okay, a to the power of m plus n equal to a to the power of m into a to the power of n, right? So if I separate them, it will become 4 to the power of minus x into 4 to the power of half, which is square root of 4 basically, into minus 7 into 2 to the power of minus x, okay, less than 4, which is nothing but, okay, 2 into 2 to the power of minus x whole square. Okay, basically this 4 I have written as 2 square. Okay, then minus 7 into 2 to the power of minus x less than 4. Now I have, if I call this as some a or b, then it will become a square minus 7a, which is a quadratic equation, is what quadratic inequality, what I will get it here, right? So let 2 power minus x equal to m. So the equation becomes 2m square minus 7m minus 4 is less than 0. Okay, now you factorize it, very easy actually. Looking at the numbers, we know we can factorize or not, so it can be factorized easily. So what you will get is m minus 4 into 2m plus 1, which is less than 0, right? So either m is less than 4 or m is less than minus half. Okay, m is less than 4 and m is less than minus half. Okay, now this is what we got, which is nothing but 2 power minus x. M is 2 power minus x. Okay, so if you see the 2 power minus x property, okay, 2 power minus x is nothing but 1 by 2 power x, correct? 1 by 2 power x is always positive. Okay, for any positive values of x, okay, or negative, you will always get 2 power minus x as positive. It can never be less than 0, right? So 2 power minus x is less than 4, okay, which means it is from 0 to 4 basically. Okay, so 2 power minus x is less than 2 square, which means minus x is less than 2, or x is greater than minus 2. Okay, so this is the range. We can ignore the negative terms. Okay, so the solution set is basically minus 2 to infinity. Okay, we don't need to consider m less than minus half, because you will never get m less than minus half value. Next, given that equation x square minus 2a plus bx plus 2a square plus b square minus b plus half equal to 0 has real roots, find the values of a and b. Okay, it is given that this has a real roots. Okay, when you will have real roots, when discriminant is basically greater than or equal to 0, right? So whenever it is given like this, discriminant is the best one to check. Okay, and also to solve such equations, basically you can check alpha beta and alpha plus beta and alpha beta. Okay, that is also useful. Okay, now let's check the discriminant and take the values from here. and simplify it, what you will get is yeah, it's here. Let me put the pointer. Okay, minus 4a square minus 3b square plus 4ab minus plus 4b minus 2 is greater than or equal to 0. Okay, simplify it further. Basically, how I want to simplify, basically I am trying to make two squares of this LHS side. Okay, that is 4a square. I will write it as first thing I have done is basically took the multiplied both the equations with minus. So the LHS side has become 4a square plus 3b square minus 4ab minus 4b plus 2, and 0 is 0 anyway, but the inequality will change. The greater than or equal to become less than or equal to now, because I multiplied with minus. Okay, now I will write 4a square, okay, and minus 4ab, then I need a b square term, right? Okay, so I added one b square term. Okay, so 2a whole square minus 2 into 2a into b plus b square plus what is remaining, 3b square. I have taken 1b square out, so 2 into b square is remaining. Okay, then minus 4b. Okay, I have taken 2 common, so it will become minus 2b plus 1. So this is also a square. Okay, now if you see it, the final expression it will become is 2a minus b whole square plus 2 into b minus 1 whole square is less than or equal to 0. Okay, now again same thing we have to apply. This is again square of some real number, right? Whether it is negative or positive, square is always positive, correct? So the two terms on the LHS side can be only positive or 0. Okay, correct? They can be only positive or 0. They cannot be negative. To become less than 0 value, they will never bring a less than 0 value in this. Maximum they can bring is 0. Correct? So only option is basically LHS side has to be 0. LHS side is 0 if and only if each term is 0. Okay? Because otherwise they are positive. They can't be negative. Right? So which means very simple. 2a minus b equal to 0 and b minus 1 equal to 0. Right? And if you resolve it, b equal to 1, this is one value, substitute the value, what you will get is a is half. This is the solution. Okay, hope you understood this part very well. Okay, this is what from number theory you will have to understand. Okay, so everywhere you have number theory playing into this polynomials. Next. Okay, this is also a BITSAT question. We need to find out the k value from this given. Okay, so this is sorry, x power 100. Okay, this is x power 100, not x 100. Okay, x power 100 is divided by x square minus 3x plus 2. Okay, and the remainder is this. Then the what is the k value? Okay, let's see. F of x equal to x power 100. Okay, g of x is this one because we are dividing with this quadratic equation. Quadratic polynomial, basically x square minus 3x plus 2, and the remainder, let's say, is ax plus b. Why I took ax plus b as remainder? Okay, think carefully. I am dividing with a x square term, so maximum remainder I will get is x power 1, right? If I get another x square term, I can divide it with x square always. So the remainder I always get is basically in the form of ax plus b. No other form is possible. Okay, and there is some quotient q of x. Okay, this is very very important and very interesting problem to solve actually. Okay, so we are going down to the basics of functions. Okay, now we know that f of x is equal to g of x into q of x. Okay, we are dividing with this number and this is the quotient, divider and quotient plus remainder. Correct, this is what is the standard formula. Now I will replace the terms. X power 100 equal to x square minus 3x plus 2 into quotient, that is q of x, which I don't know what is the value. Okay, plus ax plus b, remainder. Okay, I need to find this a and b and then equate to this terms here. Okay, now x power 100 equal to, I basically factorized this x square minus 3x plus 2 into x minus 2 into x minus 1 into q of x plus ax plus b. Okay, now For x equal to 1, what happens? For x equal to 1, this part is 0, and x equal to 2 also, this part is 0, which means I don't require what is the quotient. Basically, I don't need to know what is the quotient if I substitute x equal to 1 and x equal to 2. So first I will put x equal to 1 and this equation. So x power 100 will be 1 power 100, which is 1. So 1 is equal to, this part is 0, so I'll get a plus b. Okay, so a plus b equal to 1. This is my first equation, right? A plus b is 1 is my first equation, this one. Okay, and second equation is x equal to 2. I'll substitute 2 power 100. Okay, 2 power 100 equal to this. This is my second equation, 2a plus b. 2 power 100 equal to 2a plus b. With these two equations, I can definitely get my a and b values, right? A equal to 2 power 100 minus 1, b is equal to 2 minus 2 power 100. Okay, a equal to 2 power 100 minus 1. Okay, if you see here what form it is in, I will write it into the same form. Okay, remainder is equal to ax plus b, which is 2 power 100 minus 1 x plus 2 minus 2 power 100. Okay, now this I will put it in this form, basically 2 power k plus 1 minus 1 and 2 power k minus 1 form I will put it. How can I write it? I will write 2 power 100 as 2 power 99 plus 1, and I will take the 2 out. Okay, then it will become, and minus 2 out basically, then it will become 2 power 99 minus 1. Okay, if you compare with this equation, basically remainder here and this one, it is very obvious k is 99, correct? So this is how we should solve this problems. Okay, yeah, let's see one more problem. Read the problem. So n is a positive integer such that one of the roots of the equation 4x square minus 4 square root of 3 plus 4 into x plus square root of 3n minus 24 equal to 0 is an integer. Okay, find n. Let p be the integer root of the given equation. Let's assume p is the integer root. Okay, and then first thing what we can derive is, we can substitute p with x with p, and then rewrite the equation 4p square minus 4 square root of 3 plus 4 into p plus square root of 3n minus 24 equal to 0. This is my first equation, right? Then I am basically taking the square root term basically. Okay, so 4p square minus 4p minus 24. Okay, and then square root of 3 into 4p minus n. Okay, equal to 0. Okay, rewrote the equation like this. Okay, now I mentioned here this is true only if each term is equal to 0. Why? Because p is an integer root. Okay, p is the integer, so this value 4p square minus 4p minus 24. Okay, and then 4p minus n. Okay, both has to be zeros, because this is an integer. You cannot get a square root of 3 term here, correct? Do you get a square root of 3 term here with 4p square minus 4p minus 24 and p being the integer value? You will never get a third here, right? Square root of 3 you will never get the value here, which means 4p minus n has to be 0. Okay, and to satisfy this equation, okay, this part is 0, so this is also has to be 0. Okay, so 4p minus n equal to 0, or n is equal to 4p. Okay, and the second part 4p square minus 4p minus 24 also should be 0. Okay, now you have a quadratic equation here, which if you factorize and solve, p should be equal to minus p should be 3 or minus 2. Okay, and n is equal to 4p. If you substitute p value here, you get two values for n, that is n is equal to 12 or minus 8. 12 or minus 8, but it is given that n is a positive integer, so obviously the answer is n is equal to 12. Okay, I hope you understood this number theory concept here. 1 is a third square root of 3 term, okay, p being integer, n being positive integer. You will never get a third here, right? Square root of 3 you will never get, to cancel the square root of 3, okay, and here also you will never get a square root of 3. So only option left is each term should be equal to 0, then only this equation will become true. Correct? That is what I applied here. Okay, so answer is 12. Okay, if AB are the solutions of x square plus px plus 1 equal to 0, and CD are the solutions of x square plus qx plus 1 equal to 0, then a minus c into b minus c and a plus d and b plus d are solutions of this third equation here, x square plus ax plus beta. Then find the value of beta. Okay, so from the first equation we know that a plus b equal to minus p and ab equal to 1. A plus b equal to minus p, ab equal to 1. Okay, from the second equation we know that c plus d equal to minus q and cd equal to 1. Okay, now a minus c into b minus c and a plus d into b plus d are the roots of this equation, right? So you product of four of them, a minus c into b minus c into a plus d into b plus d equal to beta. Okay, now you expand that, ab into ab minus ac minus bc plus c square into this one. Now you simplify it further basically, okay, into this. Then you substitute a plus b is nothing but minus p, so it will become 1 plus pc plus c square. A plus d is a plus b is minus p, again you substitute it, what you will get is 1 minus pd plus d square equal to beta. Okay, then you multiply both of them, you will get this expanded value here, expanded expression here. We need to just substitute the values basically. Keep on substitute the values at the appropriate place. So since CD equal to 1, basically I removed all the CD terms. CD equal to 1, so you will get only PD. Okay, and the CD, C square, D square also 1. Okay, here CD will go, so PC only will remain. Okay, now this final expression I will get is, after simplification, is 2 plus D square plus C square minus P square equal to beta. Okay, now I will rewrite this as 2CD, because CD equal to 1 anyway, right? Because I can make a square of this one. I can make a square of this one. Now this will become, okay, this is, sorry, C plus D whole square. Okay, C plus D whole square minus P square equal to beta. Okay, which means Q square, C plus D is nothing but minus Q. So Q square minus P square equal to beta. Okay, so just you should have patience to solve such problems. This is just an expansion, and appropriate place you replace these values basically. Okay, so from the first two equations, whatever values you have to replace appropriately. So beta is Q square minus P square. Okay, thank you. So we are solving problems which are mainly above the class exams, basically board exams. These are very useful. We need to understand different patterns of problems in quadratic equations, because later we will be applying all these quadratic equations into trigonometry, in differentiation, and calculus. Everywhere we are going to geometry, we are going to apply this. So we should be very thorough with the concepts of polynomials and quadratic equations. Okay, we'll come up with more problems. Okay, wait for next two videos. Thank you.